Hi, welcome. I know why you're here, and it's not to learn calculus, it's to join me in the simultaneous sip. So if you have your coffee ready, please join me. The question we're working on today is, find an equation of the line through the point 3, 5 that cuts off the least area from the first quadrant. The equation of any line through the origin is given by y equals mx plus b. So we'll shift these lines to the right by 3 and up by 5 to get y equals m times x minus 3 plus 5. So we could start by sketching a picture of what we're dealing with. There's the point 3, 5 and some random line that goes through it. And we're going to find its area, so we should find its height, which we'll call y, and the length, which we'll call x, of this triangle. And that's just the same as finding the x-intercept, which I found to be negative 5 over m plus 3, 0, and the y-intercept, which is negative 3m plus 5. Okay, so the goal of our question is we want to minimize the area. The area of a triangle is equal to 1/2 x times y. And we have some constraint functions that we have to satisfy. So under the constraints, well, x is negative 5 over m plus 3, and y is negative 3m plus 5. So we can sub those values into a. So we have a is equal to 1/2 minus 5 over m plus 3 times minus 3m plus 5. And we can now distribute this out to get a is equal to 15 minus 9/2 m minus 25/2 m to the negative 1. And so we'll take the derivative now. So a prime is equal to negative 9/2 plus 25 over 2m squared. And we can combine this with a common denominator to get negative 9m squared plus 25 all over 2m squared. So we want to find when this derivative does not exist. And so that's when the denominator is 0, and you'll find that that's m equals 0. But that's not in the domain of our function, so we can throw that out. So now we'll find when a prime is equal to 0. That's when the numerator is 0, so negative 9m squared plus 25 is equal to 0. And that gives us m is equal to 5/3 or negative 5/3. But the question said we wanted the region to be in the first quadrant, so x and y have to be positive. So x, which we said was equal to negative 5 over m plus 3, and we found we'll try m equals 5/3 first to see if this works. That tells us that x is equal to negative 3 plus 3, which is equal to 0, which is not positive. So we could throw out the m equals 5/3 case, which leaves us with m equals negative 5/3. So to put it all together, we have y equals negative 5/3, x minus 3, plus 5. Well, thanks for stopping by. I'll see you next time. Don't text and drive. Bye-bye.